myself Dr. Divya, Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. Today in this session, we will understand the methods of green synthesis, of which one of the method is the ultrasound assisted method and its various different modes and different synthesis. So, here are the topics. Ultrasound assisted method for green synthesis. So how the method is helping us in reducing the time or the byproducts or the waste material. Then it is also called as sonochemistry. Then the sources of ultrasound that are used. So we will see in detail. Then apparatus used in sonochemistry and types of ultrasonic reactions that are used in any applications. So what is sonochemistry? So the first commercial application of ultrasound. This ultrasound is used in 1917 for the first time with the echo sounding technique. So this echo sounding technique, which is developed by Langevin, so for the estimation of depth of water. So if this is the sea, on the sea, if a boat is riding, like the depth of the sea can be estimated using echo sounding technique. For this, they utilized this ultrasound mechanism. So, for example, if this is the boat, they are creating ultrasound so that it goes to the depth. So depending on the frequency, we can achieve the depth of that particular sea. So this is how they used ultrasound technique for determining the depth of water. So this sonochemistry is used to describe physical and chemical processes occurring in solution through the energy brought by power ultrasound. So whenever the ultrasound is used, it generates some energy. So using this energy, there are some chemical or physical processes that takes place in the solution. So that is how the sonochemistry comes into play. So the effects of ultrasound are the consequences of cavitation phenomena. So how the ultrasound, how this ultrasound is giving us energy because of cavitation phenomenon. So we will see in detail how this cavitation will takes place. So which is the formation, growth and collapse of gaseous microbubbles in liquid phase. So this is nothing but, the cavitation is nothing but first the formation, growth. So once it forms and it grows and it collides. So this is how the gaseous microbubbles will occur in liquids. So this is the cavitation phenomenon, that is the basic for ultrasound effect creating energy. So generally the ultrasound or the sound waves, how is the ultrasound coming from? Sound. So sound waves travels in compression and relaxation mode. So this is the compression mode and this is the relaxation mode. Compression mode. So this is how the sound travels, which causes pressure high and low. Where the pressure, for example, when the pressure is low, it will produce a bubble. So when the pressure is low, it produces a bubble which is called as micro bubble. So the bubble is forming. When the pressure is low, it is forming a micro bubble. So, it occurs due to acoustic cavitation. Acoustic cavitation occurs when the pressure is low. So, this microbubble will grow, keep on growing, and at one point, it will become highly unstable. So, it will give rise to a bigger shape which becomes unstable in nature. So, there it undergoes implosion. So it will implode. So that is how the collapse will occur. That is how the collapse will take place. So after implosion, there will be release of energy and temperature of 4000 Kelvin and 1000 atmospheric pressure. So it releases energy at this stage. It releases energy with a temperature of 4000 Kelvin, 4000 Kelvin and 1000 atmospheric pressure. This is how the bubble, micro bubble grows, keeps on growing. There is a growth. After growth, it reaches the highest possible size of that bubble, which causes implosion. So that is how it produces energy. So the sound waves having high frequencies are known as ultrasound waves. So whenever sound waves is having higher frequencies, it is called ultrasound waves. It is about 20 to 100 kilohertz. So the ultrasound is generated with an instrument having an ultrasonic transducer. So this is the instrument that they use for generating ultrasound waves. So this is a device by which electrical or mechanical energy can be converted into sound energy. So this is an instrument where electrical or mechanical energy is converting into sound energy. So commonly used ultrasonic transducers is quartz. So commonly used is material used is quartz, but in modern ultrasonic equipment, ceramic impregnated barium titanate is used as transducer, which converts. So this is the latest one where we use ceramic impregnated barium titanate. So that is a material we use in producing the ultrasound waves. So about 95% of electrical energy is converted into ultrasound. So this will help in getting more output from that particular transducer. So this is how there is a development even in the materials that are used in the ultrasound transducers. So these are worked based on piezoelectric effect. So it is nothing but unequal and reversing charges are applied to opposite faces of transducer, resulting generation of vibrations by expansion and contraction of transducer, which emits ultrasonic waves. So depending on the piezoelectric effect, the ultrasound waves are produced. So we will see one by one the different types of transducers that are used and their mechanism, how they will be working. So under appropriate conditions, so at the particular condition, the attractive forces of any molecule, for example, we have a solvent liquid. So it has some molecules. So these molecules under some condition, at some condition, attractive forces will overcome. That means the atoms that are together due to attractive forces will overcome, forming a bubble. So this will form a bubble. So, and this will grow and collapse, which is due to internal forces in the bubbles. This also has internal forces. This bubble will have internal forces. So that is how the implosion takes place. So bubble collapse in liquid, forming enormous amount of energy from the conversion of kinetic energy of a liquid into heating the contents of bubble. So this is how the cavitation takes place for any particular liquid or solution or solvent, so that the energy is produced. So this energy will be used in the synthesis. So experimental results showed that these bubbles have temperature of 5000 Kelvin, pressure roughly 1000 atmospheric pressure, and cooling rates of around 10 part 10 Kelvin per second. So these are the good characteristics of this method, where we can apply, it will produce enough heat for the synthesis to takes place. So this sonochemistry in chemical synthesis, how it does take place because of physical and chemical effects from the ultrasound due to cavitation phenomenon. That is, we have already discussed cavitation phenomenon. So the ultrasonic frequencies doesn't even change the rotational and vibrational frequencies of molecules. So the molecule's rotation or the vibration is not changed due to these ultrasonic waves or frequencies. Only because just because of cavitational collapse, there is sufficient kinetic energy that will be produced, that will help in the reaction, chemical reaction or transformation of reactants into products. So, for example, in case of water, the cavitational impulsion leads to production of solvent radicals. So, because it is producing high energy and high temperature, enough amount of energy, radical type of reaction can take place. So, that is the the H radical and the OH radical, hydrogen radical and the hydroxyl radical generally produced from a water. So this radical species can react with each other to give hydrogen and hydrogen peroxide. So for example, in aqueous medium, we generally we use water. So this water will be giving rise to hydrogen radical and hydroxyl radical. These will react again with the presence of other radicals and form hydrogen and hydrogen peroxide. So they are reactive. They also can react with other substances to induce secondary reduction and oxidation reactions. So this will keep on reacting with other substances also to produce secondary reduction and oxidation reactions. So all this mechanism or the synthesis takes place just because of ultrasound waves. So how these waves are produced? Just from the ultrasound transducers. So it's a device by which electrical or chemical mechanical energy can be converted to a sound energy. Electrical or mechanical energy can be converted to sound energy. So for example, these are the different types we use: liquid driven transducer, magnetostrictic transducer, piezoelectric transducer. So these are the three different transducers we use for the generation of ultrasound waves. So if we go in detail, liquid driven transducer, these are liquid vessels where a liquid is forced out of an orifice. Orifice is nothing but a hole. So and across a thin steel blade. So what happens? We are sending liquid from this orifice. So once the liquid is passing through this orifice, there are some steel blades present here. Stainless steel blade. This is the steel blade. And also thin metal blade. This is the metal blade that is present. Because of this, there is when a liquid is pumped and striking a obstruction or a metal or any obstruction, it forms droplets. So these droplets is forming just because of two sources. So this is nothing but from droplets, it forms bubbles. So that is the main concept of cavitation. So how does this occur? This occurs from the vibration of blade. So this vibration, this blade will be vibrating, causing the liquid flow. Just because the flowing liquid splits because of vibration of blade, and a Venturi effect where as a liquid emerges as a jet. So this is nothing but when it is when the blade is vibrating, the liquid will be forming a jet of droplets which consists of bubbles forming cavitational phenomenon. So this style of transducer is very effective in mixing and dispersion. So for mixing of solvents, immiscible solvents, this mechanism is very useful, but is not generally used for sonochemical reactions which requires high energy, because it does not produce high energy. So any reaction that requires high energy, this transducer cannot be used. So that is how this liquid driven transducer works. So it is just like liquid is passing through this orifice and striking the stainless steel blade. And because of vibration of this blade, there is a droplet or the Venturi effect taking place, forming a jet of droplets which is having bubbles. So these bubbles will grow and then give rise to because of this cavitation formation, there is reaction going on. So next is the magnetostrictic transducer. So these are electromechanical devices that use magnetostriction, an effect found in some ferromagnetic materials. So in this type of transducer, ferromagnetic materials will be used, for example nickel. So this will help in producing the required output of energy for the synthesis. So such materials reduce in size when placed under magnetic field. So it has influence of magnetic field. So whenever nickel is placed in magnetic field, it will reduce in size and return to their normal size when when the magnetic field is removed. So this type of transducer is constructed using laminated nickel as the core of solenoid. So for example, this is the magnetic field. This is the magnetic field that is around the material that we are using. So there is an increase and decrease of size of that particular metal or the ferromagnetic material. So because of that, there is vibration taking place, and because of that vibrating, this electrical input, whatever the energy we are giving an electrical input, will give us a sound or the vibration, ultrasound waves, as ultrasound waves. So which is having higher frequency because of the vibration of materials that are used under magnetic field. It forms ultrasound waves. So these will be used for synthesis. Next is the piezoelectric transducer. So these are the most common and the latest one using for the generation of ultrasonic waves. In general, what happens? This element, the piezoelectric elements are present like barium titanate that is used. So they will vibrate to generate a sound wave when applied a voltage. Nothing but we are giving some energy to the piezoelectric material. Just like a magnetic field, here we are, the material itself is acting and giving a vibration, converting to a sound wave. So this is because of applied voltage. So the piezoelectric the ceramic element commonly used in ultrasound cleaners and for probe systems is produced in the form of disc with a central hole. So it will form it is having a disc with a hole here. So this is the hole. So the material will be having a hole. So whenever there is an input of energy or the electrical energy is given, the element or the piezo element will vibrate, giving rise to ultrasound waves. So this is the just phenomenon and the main principle based on which piezoelectric transducer will be working. So usually two elements are combined so that the overall mechanical motion is additive. It means it gives good amount of energy. So what are the apparatus? Next comes the apparatus used in sonochemistry. Ultrasonic cleaning bath. So we generally use mostly in the laboratories that ultrasonic bath for agitation and other purposes. So here we are using the same method for producing the energy. So ultrasound waves that will be giving rise to favoring the synthesis of any chemical reaction. So it involves the immersion of standard reaction vessels, glass reaction vessels into the bath. So it has water plus detergent that can be used. So this is the transducers that are used for creating vibrations. So that will produce vibrations, and this is the glass vessel with with reactants, for example. So if they are immersed into the water, this will the vibration will help in mixing, and also the synthesis will force the reactants to react together. So this is important because conventional apparatus can be transferred directly into the bath. So an inert atmosphere, our static pressure can be achieved readily to maintain throughout this sonochemical reaction. Most of green synthesis is done using this ultrasonic bath. So it is simple and reliable technique that can be used for any chemical synthesis. Therefore, it is green synthesis. The input of electrical energy is also very low. So even for the production plants, it works well. So it is important to establish optimum position of the reaction vessels in bath, both horizontally and vertically. For example, if we are using it horizontally or vertically, the position of that particular vessel is very, very important, because the rate of vibration of the vessel can vary when it is placed at different places in the ultrasonic bath. So it is very important to optimize that position of reaction vessel for this type of reaction technique. Then is the ultrasonic probe. So we are using previously we have used inserting the vessels into the ultrasonic bath, but here what we are doing, we are just inserting the probe inside the vessel itself, in order to increase the amount of ultrasonic power available to the reaction. So what happens in this? Whenever we are inserting this probe into the reaction vessel, the vibration will increase. It means the sound waves or the ultrasound waves will increase, so that reaction is, there is no loss of these waves to any surroundings. It is directly giving the sound waves to the reactants. So the rate of reaction also may increase. So it can be attained by introducing the energy directly into the system, rather than rely on its transfer through water of a tank and a reaction vessel. So if we are immersing into a ultrasonic bath, there is a chance, this is the vibration occurring, there is a chance of vibration or the energy loss in this method, but in probe there is no energy loss. So this is how we aim in increasing the reaction rate. So this is the simplest method to achieve achieving this high energy or good reaction rate is to introduce ultrasonically vibrating tip of a sonic probe into the reaction vessel itself. So this is a simple way when compared to the ultrasonic bath. So what are the advantages of probe system over bath system? One can control ultrasonic power delivered to the reaction in probe system. Then maximum powers of several hundred watts per square centimeter can be achieved easily. So wherever we are introducing the probe, there is no loss of energy, and also the wattage or the input of electrical energy will also be reduced, because the area will be reduced, producing vibrations or sound waves will be reducing. So ultrasonic streaming from the tip of the probe often is sufficiently powerful to produce bulk mixing without the need of additional steering. So whenever we are introducing the probe inside the reaction vessel, so we are really using it like it will be helping in mixing, because we are directly introducing into the solution. So if, for example, when it is immersed into the bath, the mixing will be because of a transfer of these waves into the vessel. So that takes longer time when compared to probe method. So in probe method, it is very easy for bulk mixing without any stirrer beads using. So no additional stirrer can be using. So we need not use any additional stirring to achieve mixing. So this is like ultrasound waves will help in changing the reactants into products because of its chemical reactivity. So that will help or make the reactants work together for producing products. So this is the probe method, and this is the bath. These are the two we are using. So it is all depending on the cavitations that are producing. So upon irradiation with high sound ultra waves which are propagated, a series of refraction cycles takes place. So pass through the liquid medium, causing oscillation of molecules. So this is very important. The reaction will take place because of oscillation of molecules present in solution or the reactants. Molecules is nothing but here reactants. So this will help in forming products. So there are different types of sonochemical reactions. First one is the homogeneous reaction. So what happens in this? There is sonolysis of water. So the water splitting is also very important, wherein we generally mostly use water as a media for the reactants to take place, for the reaction to take place. So which produces both strong reductants and oxidants, is capable of causing secondary oxidation reduction reaction. So that will help in giving oxidation reduction reactions, thereby producing products from the reactants. So the OH radicals produced from the sonolysis of water are able to attack essentially all organic compounds. So this has high reactivity. So these will be attacking the organic compounds including halocarbons, pesticides and nitroaromatics. So these are the organic compounds that can be attacked by the hydroxyl radical, and through a series of reactions they oxidize them completely. So whenever there is a formation of bubble, so this all will take place just because of cavitation phenomenon. So in this cavitation, a bubble is forming. So whenever there is a formation of bubble, it is again surrounded by hydroxyl radicals. If you see this schematic, there is a formation of hydroxyl radicals around this bubble. So this bubble has all the hydroxyl radicals. So this will be attacking the organic compounds. So these hydroxyl ions with organics will produce carbon dioxide and water. So thereby oxidizing all the organic matter in that particular reaction, or the organic compounds present in particular reaction. So this is how the bulk reaction takes place in the bulk solution. So these are the main radical formation of radical is an important step. This will help in attacking the organic compounds present in the reaction, and they split into and they form the carbon dioxide and water. So the ultrasonic irradiation of organic liquids create the same kinds of products produced with very high temperature pyrolysis. So this reaction will favor with the same reaction wherein we are using very high temperatures for pyrolysis reaction. So with this simple method, we can produce the same products that are produced from high temperature reactions. So examples are hydrolysis of nitrile in acidic or basic conditions. So this hydrolysis of nitriles takes place in both acidic or basic conditions as hydrolysis of benzonitriles. So benzonitriles under thermal or ultrasound using 2 molar HCl or 2 molar sodium hydroxide. So this is base, this is acid. We can use either acid or base with improvement of reaction time from 8 hours to 45 minutes. So what is happening here? We are having nitriles. So these nitriles either in acidic or basic, either acidic or basic medium, they can form benzonitriles. So this will hydrolysis can takes place with H plus or OH minus ions. So this reaction, conventional reaction takes place, conventional reaction, it means thermal method under temperatures will takes place in 8 hours. But in sonochemical reaction, it will happen in 45 minutes, which is very less when compared to the conventional method. So this is the improvement of that reaction. The reaction will be faster so that the products produced will be in no time, so less time. It takes place in less time. So experimental condition for hydrolysis of benzonitrile under thermal or ultrasonic activation in acidic or basic medium. For aromatic compounds, benzonitrile hydrolysis takes place. Benzonitrile hydrolysis takes place. Hydrolysis of this benzonitrile occurs in acidic or basic medium. So this is under ultrasonic condition, it will occur just in 45 minutes. So this is the best example. Here it is taking 8 hours, but here it is happening only in 45 minutes. This is the conventional method. This is the sonochemical method or ultrasonic activation. So the two methods, conventional method and sonochemical method. Here it is only 45 minutes that is taking. However, it is 8 hours for the conventional method. So this is how the reaction time will be reduced. Next comes the sonochemical solvolysis of 2-chloro-2-methyl-propane in aqueous ethanol. So here what happens? The ratio of first order rate reaction constants K ultimate in the presence of ultrasound, K ultrasound and K conventional conditions are compared. So the reaction rate constants, the other way is the rate constant comparison, wherein we compare the rate constants of both the reactions in conventional method and ultrasound method. So the sonochemical method is more efficient on lowering the temperature. So at lower temperatures also the reaction will takes place under this ultrasound waves mechanism. About 20-fold increase in reaction rate. So reaction rate is around 20 times higher when the temperature is reduced to 10 degrees centigrade when compared to conventional method. So this is under ultrasound waves. When 10 degrees is sufficient for the reaction to take place. So due to reduction in vapor pressure by lowering of reaction temperature will increase the cavitation bubble collapse. So this will produce energy and hence the sonochemical effect. So what happens when the vapor pressure is reduced for any liquid, the temperature will be under lower temperatures. So under lower temperatures, what happen? The vapor pressure will be reducing. So that will increase the bubble formation increases. So that will increase the collapse also. So when the collapse is increasing, the energy produced also increases. That is nothing but the sonochemical effect. So if we see the ultrasound, this is the 17.2 into 10 power 5 is the reaction rate constant, but for the conventional method it is around 0.86, and even at the temperature of 25 degrees we use, it is only 6.8 in the conventional method, whereas it is 11.4 in the ultrasound method. So with this we can understand that ultrasound method gives efficient reaction or uses energy efficiently to produce products. So next is other type is a heterogeneous reactions. In heterogeneous reactions, what happens? Liquid-liquid or liquid-solid ionic reactions takes place, like mechanical effects associated with sound waves can affect both rates and yield. Yield is also very important. So yield to an extent depending on the characteristics of that particular solution system or the reactants that is but the system, such as surface tension, density, temperature or nature of solids. So the rate of the reaction and yield both are varying depending on the surface tension, density, temperature or nature of solids in this particular reaction. That is between liquid-liquid or liquid-solid ionic interactions takes place. So in the former reactions, cavitational collapse at or near the interface will cause disruption and mixing, resulting in formation of emulsions. So what happens? The cavitational collapse, the bubbles after forming and achieving its unstability stage, it will be collapsing. So this will produce energy at the interface, giving rise to mixing phenomenon, forming emulsions of that particular solutions. So there are two types of reactions that will be taking place in solid liquid reactions. In type 1, in this solid serves as the solid will serve as one of the reagent and is consumed during reactions. So we are taking a solid and a liquid. So this solid will act as reactant. So that will be consumed during the reactions. This is used to improve the yield and it is due to dispersion and microstreaming effect of ultrasound. So this ultrasound plays an important role in dispersion and microstreaming of that particular reactants. So that will give rise to products and so the solid will be consumed during the reaction. In the other step, metal. In this, metal functions either as a catalyst or is consumed. So it will just, when it is acting as a catalyst, it will just act like increase the rate of reaction, favoring the formation of products. So the major effect which is observed under when ultrasonic waves propagates. So this the major effect is the formation using the metal as catalyst or can be used as a reactant. So it will follow just the erosion of metals can be followed in this sequence. It will be high for the lead, then is a magnesium, zinc, tin and copper. So this has the effect, the major effect on the metals. So mostly lead will be consumed, then magnesium, then zinc, tin and copper. So this is one of the example wherein sodium hypochlorite will be reacting with an aromatic halide and forms the product. So this is because of some catalyst that can be, the metal used can be like acting as a catalyst or consumed. Catalyst giving rise to products. This is one of the type of reaction that will take place during sonochemical effect forming the products. So these are the reaction, different types of reaction. In the next session, we will see the application part. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.